Hello, everybody. Good morning to all. My name is Jose Carlos Diaz, and I am the International Sales Manager of NADS. NADS, Next Aerospace Defense and Security, is a leading European provider of innovative simulation and C4I solutions in the military and the aerospace markets. And we are a provider of disruptive innovations in the modeling and simulation industry, leading the introduction of an interoperable open architecture in simulation in the form of our product SimWare. SimWare is our flagship product and is the first DDS and HLA compliant open architecture for distributed simulation, which is available worldwide. And this webinar will be about the latest SISO initiative regarding the developing of a new layer service architecture, which could be based in DDS also for the communications of the distributed nodes of any simulation. Following to this short introduction, José Ramón Martínez Salillo, which is our pre-sales team director, will talk about the SISO's LSA initiative as well as the linking points with our product SimWare. And we hope that you will find it very interesting, and at the end we will have a short time for your questions. So please use our chat tool within our tool for this webinar. We have the typical chat tool, the typical question and answer tool to send us all the questions you may have. So then, José Ramón, proceed.
Good morning to everyone. So, this is the agenda of the webinar. First, we will talk briefly about the use of DDS specifically in simulation. Here, we are not going to enter into detail of DDS, what is DDS, etc., because this is not the focus of the webinar. Then, we will talk about the LSA study group in SISO, how is the architecture proposed, etc., the main ideas in this group. Then we will talk about SimWare very briefly also, only 4 slides, because again, this is not a webinar about SimWare. Then we will talk about how SimWare fits into this LSA model, into this LSA architecture, and what we are thinking about aiming our product, our framework to this architecture. And after that, we will have a brief summary and some questions. Feel free of asking any question in the question box of the webinar. And at the end, we will have about 10 to 15 minutes to answer all these questions. Well, the first thing is DDS in simulation. Well, DDS was born in 2003, before 2003 indeed, as a real-time backbone for frigates in Holland. After that, it was standardized in OMG, and then it became a full spectrum of authorizations. The key point here was that one of the main companies decided to go open. They decided to put the code in an open way. So after putting the code in an open structure, a lot of people downloaded this code, and then it started to use them in a lot of new applications. For example, they are using it now in simulation. They are using it now in real-time embedded system. They are using it now in telescopes, for example. In the European telescopes in Chile, they are using it. In smart grids, in smart cities, they are using it. In SCADA, which is very interesting because they have a lot of new interesting SCADA about using this kind of technology. In business intelligence, I mean all these brokers that are in a little office connecting to the markets and having very brief, very fast connections to markets. In medicine also. So the idea is that from the beginning, a lot of features of DDS has been interesting for a lot of applications, and each of these applications, each of these walls, each of these RTIs, SCADAs, etc., uses different features of DDS that are very interesting. But here we are trying to use DDS for simulation. And what's the idea? Okay, DDS has a lot of things that are very, very useful for simulation. In the communication, DDS is based, or centered if you want, in the communication. It's based on controlling the communication for real-time restrictions. The idea is you have a lot of quality of services to control the communication, to control the way the information is sent, kept, established, etc. in any network. On the other hand, for example, HLA has a lot of structures to try to avoid having communications. I mean, the idea is, okay, you have a network, but sometimes you can't control this network because in HLA you have some, but not a lot of ways of controlling the network. So then try to avoid overwhelming this network. Try to avoid using this network too much. So HLA is full of mechanisms of updating under demand, of different regions, of type management, for example. And the main idea, the central idea here is don't use the net if you don't need it. If you don't need it, take the ownership to the other place. If you don't need it, etc. This is the key difference. With DDS is trying to control the communication and using the communication, and with HLA is, okay, don't use the communication if you don't need it. With DIS it's even more simple. You only have to trust the communication, more or less. Also, scalability and fault tolerance. Well, DDS has automatic discovery, real automatic discovery. Just in seconds, you can join an already existing network. It's fully published and subscribed, so there is no single point of failure. And also, with the quality of services, they have a lot of mechanisms you can use for redundancy. For not having a single point of failure, you can, for example, detect if your node goes down and recover it. Or you can, for example, have more than one node, and in this case I mean node by the simulations, for example. More than one simulation doing the same thing, but with different strengths, with different quality of services. So at the end, you can have full redundancy. With HLA, it's not the same story. With HLA, all the exercise they have done with hundreds of thousands of nodes has the same results. In this exercise, all the nodes, all the simulations joined together fall more than once. And you can easily recover this. With this, it's very easy to rejoin, it's very easy to add new elements with the same rights as the former. And even you can recover automatically some information you have missed because you have, for example, history that is a quality of service you can use for saving in your local memory all the data related, for example, with one topic. So you can have a lot of ways of having redundancy and fault tolerance. Also, with DDS, you can cope with less than perfect communications. I mean, the idea when creating HLA was that, okay, you want to join together different simulations, in a joint simulation. But the network somehow is going to be perfect. It's going to be okay. But then in some exercise, in some real simulation, for example, the communication is not so good. You don't have this broad language. So we have made, for example, test with a small language with, in this case, 4,800 baud. And with DDS, you can communicate in this kind of language. Of course, nothing comes free. You have a lot of latency in this world. But the idea is, okay, with DDS, you can communicate even if the network is not okay. Even in networks where a simple ping is impossible. With HLA, this is impossible. What else? Real-time simulation. A lot of military platforms, especially in the US, but not only, use DDS as a communication backbone. All the systems in frigates, for example, use DDS as the way they communicate. So this allows us, by using DDS, to do two things. In the real life, in the real exercise, in the real time world, we can use DDS to make a simulation doing a what if. What if I now send this missile? What if I now, etc. And you can do that in real time because we are dealing with the same DDS as your military platform, your military ship, for example, is dealing with. Also, the opposite is true. You can add these real elements in real time to your simulation. You can say, okay, this radar that uses DDS, send this information through DDS, and I will read this information because in my simulation I'm using the same DDS. And everything is related with data here. If they speak DDS and I speak DDS and the data are the same, I can use this data in real time. And here is always the same question. What want you to do with DDS and HLA? Do you want to change HLA with DDS? And the answer is yes and no. Yes, you can change HLA with DDS. It's okay. Why? Because at the end, a lot of things are the same or can be made the same by using quality of services. A lot of services of HLA can be made redundant or even made with DDS. For example, you can discuss that maybe you don't need the ownership transfer with DDS. Can be. But not all the things in HLA can be done with DDS as is. I mean, for example, time management, as a typical example, cannot be done with DDS. So, usually, the idea is not changing HLA with DDS. Also, another strong point is that the industry is using HLA. So, don't try to change HLA. Just change the HLA RTI. Because one of the weak points, if you can say that is not so weak, but the idea is one of the problems is the RTI of HLA. The problems with scalability, of the problems with, well, even with heterogeneous networks, for example, are in the HLA RTI part, in the communication part. The problems with not having a common standard is in the HLA RTI. So the idea is, okay, let's use DDS as this common HLA RTI for every HLA vendor. So also here we can take advantage of how DDS deals with the communication, with the quality of services, etc. So usually the argument is, okay, don't try to change HLA with DDS, but try to complement HLA with the DDS using it as the HLA RTI. Of course, final thing here, in ADS, in my company, we are making simulators with DDS with the same capabilities of an HLA. So you can do it. Well, this is the core of the webinar, the study group in SISO. Well, what is the rationale here? The rationale here is trying to use the latest advantage in data-centric middleware, in net-centric interoperability, trying to have open system architecture just to solve the questions or the problems or the new requisites of the simulation architectures that are right now. You have a lot of studies. You have a LV car study, for example, and then you find a lot of questions about how these standards, how DIS, how HLA, how TINA, etc., deals with new requisites and a lot of new requirements, especially in communication, appears here. So the idea with the group in SISO is, okay, let's standardize a way of using a new this new middleware data-centric, this net-centric interoperability to solve these questions, not only centering HLA, but also for DIS, but also for TINA, but also for the future. Okay, don't reinvent the wheel. Don't try to create a new big standard for simulation, a super HLA or whatever. Just take HLA, just take DIS, just take TINA as they are, and then add a new layer for dealing with the communication and more things than that. So this initiative has been presented in SISO Fall, and there is a study group right now. There will be a progress report in 2003 spring the SISO, and a final report is expected in SISO Fall. And the idea that was presented in this group, and indeed was in a discussion group, a very open group indeed, very rich suggestions were there, was to establish somehow a new architecture based on DDS and with some layers. And here the idea is, again, not reinventing the wheel, is using the standards on simulation and using DDS as a solution of some problems, of some common problems. And which are the layers? Well, the underneath layer is using DDSI. DDSI is the standard into DDS for Open Wide Protocol. All the vendors of DDS right now speak DDSI. So no matter which vendor you are using of DDS, you will have the same communication layer. And this is very important because in HLA, they haven't reached this thing yet. In HLA, each vendor speaks his own version of HLA RTI. This wide protocol has been proved, and all the vendors comply with it. Over this protocol, we can have a middleware API for DDS, just an API. And over it, we are proposing to have two things. One of these is a simulation service layer that is more or less a plugin layer. And the idea here is, okay, with DDS, you don't have, for example, typical time management. But we can have also another services. Why not thinking about new services in simulation? Why not thinking in a way of standardizing the way they connect to this layer? For example, a terrain service. Whatever service you can imagine, TG's related services can be added here also. So the idea is having here a plugin or like that, a common way of joining these services in an agnostic way. I mean, each every vendor can add its own services here. Also, we need an API coupler, an API coupler. And this API coupler is just to connect with already existing things. The main idea with LSA group, the first idea, the first slide indeed in the group was, okay, we are not against HLA, we are not trying to fight against DIS. We are trying to make this thing to connect everything together, but not trying to substitute you. So we are going to make any needed coupler, any needed gateway to connect with you. So at the end, what you will have is a new way of communicating already existing simulations. And this is the key point with LSA, to be open, to find all the possible ways to connect everything. For example, you can have legacy applications, and with legacy I mean already existing things in HLA and DIS, and you can connect with gateways, traditional gateways. Why not try to standardize this way? Second thing, you can add DDS-based simulators. This is possible, we have made it. We have DDS pure simulations and simulators. Another thing is using this API coupler and connecting just the HLA and DIS as they are straightforward to the core. And finally, we can try another approach that is having, for example, HLA built over DDS without the gateways, or DIS built over DDS without gateways. So the idea is having all the possible ways, considering all the possible ways to connect to this core. So not reinventing the wheel, not reinventing anything, is trying to connect existing things together. Of course, you can see that this thing is very open. A lot of things can be in this architecture. Maybe not all of them could be exploited at the end, but if you're interested, you can join this group and exploit some of these things, because for example, we can talk about having a common way of controlling the simulation, or you can talk here about normalizing the gateways. Why not? In the meeting, what happened was that, well, the interest was very great, and they found, for starting, 4 topics. One was defining how to use DDS for distributed simulation. The other has defining gateways between DIS and DDS, because, you know, everybody speaks about joint simulation, about full interoperability, but at the end, the industry, the real thing is gateways. At the end, everybody is talking about gateways. So it's not strange that the starting point for this group should be gateways. Gateways between DIS and DDS, gateways between HLA and DDS, and defining how to use DDS under this API. They have prioritized because of the volunteer people, not because of anything else. The first 3 and then the 4th. But again, this is an open group, this is an open architecture, this is a study group, so if you are interested in participating in this group and want to explore another way of doing things into this group, this will be welcome. Also, they found some liaisons with another SISO groups, which is very important. For example, with CBML group. CBML is a group that is trying to standardize a common way of communicating in the battleground. Well, they have a lot of ways of communications in CVML, and they want to use DDS as another way of communication and as another alternative. Maybe you are in the battlefield and you want to communicate with another people, and maybe you can use DDS as a way. Also with the BOM group, what is base object model, they have some liaisons here because they are studying how to standardize models. So what is implicit in LSA is that some standardized way of doing things will arouse for sure. Also, another group is ANDEM, Architecture Neutral Data Exchange Model, that is very close also. And also with DDS group in OMG. OMG is the group that standardizes UML, that standardizes, for example, DDS. And following the story of this group has grown, the standard indeed has grown, following the industry, following the projects. For example, following some projects with SCADA, the standard has grown to accomplish this. And why not following simulation, they can grow also. For example, some of the vendors now are thinking about having a recorder incorporated in DDS. So this recorded thing can be used in the briefing. So maybe we can standardize or normalize in DDS OMG how to make and use this recorder, because it's very interesting for simulation work. Well, here we are going to talk briefly about SimWare. SimWare has three main pillars. Of course, it's a full framework, has a lot of tools. I'm not going to enter into this detail here. Well, the first main thing with SimWare is that can be used for create new simulators. Starting just from scratch, starting just from data, you can create new simulators without seeing the code, any code indeed. Of course, these simulators will be very basic. I mean, we don't provide with visual tools, for example, but you can create full simulators working together with any data model, and you can control them also. So in our trial pack, for example, there is a full example. You can create this from scratch very easily, very fast. In this approach, you only have to care about data model, of course. And in SimWare, all the backbone, all the communication is in DDS. We don't have any trick here. We don't use any wired thing. We don't use any back way of doing things. Everything here is using with publishing and subscribing. Even the control of the simulation, even for example, the ownership transfer is done by DDS. So this is a typical example of how DDS can be used to somehow substituting HLA. Also with SimWare, you can manage simulators. You can create the simulators and you can control them. You can control the new simulations you have made on the old simulations also. Well, you can make your own simulation and control them with some tools we have. You can control the state machine, you can control anything. Finally, with SimWare, you can make joint simulations, especially with already existing simulations. you can have an HLA simulator as is, no changing anything, no changing a comma, and you can connect it to a DDS-based simulation controlled by SimWare. You can do that with DIS. Well, we are working on it right now. We can do that on pitch HLA, and this is working, with Mac HLA. And also you can incorporate live data of DDS simulations, because we deal with DDS. So if you deal with DDS in your real element, we can read this information and send this information. Well, here in our company, we like to say that SimWare is the IRC revolution. No, it's interoperability, reusability, and composability. Interoperability for sure, because we are using DDS as the backbone and we can connect to HLA or wherever. Reusability because one thing, we can use DDS, so we can reuse elements that send, publish, and subscribe, but also because we can make models by using, in this case, well, we use MATLAB, but it's not mandatory. But wrapping them in DDS again in our architecture, you can reduce these models from one simulation to another simulation. And also compose these things, because we don't have any trick here. We use DDS for everything. We send data, publish and subscribe data. So anything can be joined in the same simulation if this element speaks the same data language, if this element speaks the same DDS language. So this is also true if the model is not just the same, but some part of it is the same. Because in DDS world, in publish and subscribing, you don't have to have all the data model mapped. You only need to know the things you need to publish and subscribe. So maybe a new element won't be fully compliant with the data model you're using, but if this model uses some part of the data, then could be composed with the rest. So how is SimWare related with this model? Related with this LSA architecture? Well, here we have the architecture. The first thing is that we have a runtime simulation infrastructure that is in the core of this architecture. It runs over a DDS backbone. So we are dealing with the same idea that LSA. We are having an API of DDS. We are using DDSI. We are using an API. Maybe not the final API of this group, maybe not so standard, but we are using it now. The same, for example, in HLA Agile, you have the same idea of API, in this case based on HLA only. What else? We have model driving development tools. We can create new models in SimWare world using MATLAB, but not mandatory. So we can have these DDS simulators running. Also, we have tools for creating gateways. Again, these gateways, at the end, maybe the way we do that won't be the standard way. But we can connect to, for example, HLA things, or in the future with DIS things, by using these gateways. And finally, we have another product that is a HLA thing built over DDS. In this case, it's an HLA API running over DDS. So we fit perfectly. We fit perfectly in this model. But also, we are very committed with this group. We are trying to improve our product, our framework, just to cover more of this model, because we feel that this model could be great for the industry. So what are we planning to do? For example, we are planning to finish our version of RTI. Our version of RTI right now has only 4 services. We are planning to have all these services. And we are planning to certify this version. For example, we are making right now data breaches, a tool for data breaches, the same tool indeed we use for HLA and DDS, for building data breaches with DIS. Also, we are thinking about making DIS over DDS without data breaching. And also we are developing ideas about how to reduce models, how to standardize the way the models are incorporated. And here we are planning to write something with some people of CAA people in Canada, in this case. Well, so we are very active in LSA, and our idea is try to aim the product, to center the product in this idea of LSA. Well, as a summary, get involved in LSA if you want. LSA is very open. LSA is a full set of ideas. So if you want, you can be involved and you can develop your own set of ideas. For example, why not standardize gateways in a multiple way? Why not standardize the control state machine? And all these things can be in LSA if you want. Just be involved. That's all. Just find new approaches. If you want to contact the person in charge of this group, is Dan Gregory from Thales, and he will be glad to have volunteers to deal with all these things. And finally, if you're interested, we have a trial version, a trial pack of SimWare. You can have it for free. You can test SimWare in a trial pack, 30 days, 60 days, what you need. And in this pack, you have all SimWare, the full SimWare with the full capabilities, and also the SimWare RTI. We can deliver to you this trial pack, have a trial version for you, and it's a full version of all the documentation. Nothing is hidden here, so you can use it fully. So right now we have the chance for some questions. Here we have the chat with the question thing, okay?
Okay, thank you very much, Ramon. We have the first question is there are too many third-party codes allowing interoperability. Why to support a new LSA style middleware?
Well, here the idea is not supporting a new middleware, not reinventing the wheel. The idea is, okay, in the market there has been a lot of good ideas about interoperability and middleware. There are a lot of standards we can use. Why not standardize that? We are not trying to make new codes, or we are not trying to make a new standard, a new full simulation standard. We are trying to reuse the pieces that are useful of all these ideas and build something useful for everybody. So maybe, I don't know, maybe the pitch people will find interesting to build a DDS layer for their own HLA. They can do it. In HLA, they are not obliged to use TCP or whatever. They can use DDS, for example.
Mm-hmm. Thank you. We have another question. Does SimWare support interoperability with DIS?
Oh, well, not yet. Not yet. We are working on it. Well, the idea is, okay, we have a tool for making data reaches with HLA of Mac and pitch. And now we are changing this tool also for dealing with some PDUs of DIS. We are thinking about having, I don't know the exact number, but more or less 60 PDUs. And I don't know now the version, but I think it's version 7. And right now we are working on it. And it's not hard to have that because at the end, DIS is not so complex, no? It's harder to have it with HLA.
Okay, thank you. I recall you to make any question. We have another question today. Today, gateways represents an important part of the overall cost of any battle lab and other kind of distributed simulation infrastructures. So the question is, how does LSA and or SimWare contribute to lower this cost?
Well, the idea is trying to use open standards. So by using open standards, you won't be bound to any vendor. No, the idea is, okay, if you can use any HLA or you can use any DDS vendor, then cost will be lower, of course, because you will have more competence and you will be able to change from one vendor to another. So there you will have a real competence. There the vendors will have to ask you for going with them. And now it's the opposite.
Okay. Of course, answering to some question of
Read it.
good morning, I would like to ask if the slide will be distributed, of course.
Yeah, sure. Yeah.
The slides will be distributed just after this webinar.
And also will be in slide share. Yeah.
We have another question about the evaluation of SimWare. How does it work if we want to evaluate SimWare? What do you propose?
Well,
it's easy.
It's easy. Well, we can give you the CD with the full version. We can give you a temporal license. And there you have all the product with all the features, with a lot of examples, with some working code you can use, change, etc. And anything is there. Nothing is hidden. You won't have any limitation there. So it's just asking us for the CD and then using it. And also we are thinking about making some webinar of how to use this CD, to how to unpack and install. That is very easy, by the way. And then to make some examples of this. So feel free of asking us about this trial pack. Another question here.
Yeah. Good morning. I would like to ask if the slide... No, okay. That's the same.
The next.
Okay. So, yeah. Is there any performance modeling plan in the LSA group already? For example, to support assessment of the performance of individual
LSA implementations.
LSA implementations. Yeah.
Well, nothing I know now about that. I mean, I think there is no one, but this is a very interesting thing. As I said before, if you want to introduce this in LSA, I think this could be great. Why not? Because maybe nobody has thought about this in LSA, but could be great to have some, maybe some common way of performance modeling or tuning. No, I don't know. It's very, very interesting. Yeah, could be great. Well, another question.
Okay. If there are no more questions, then we will finish here. We'd like to thank you all for your attendance, and we hope to hear from you very soon. You have our contacts, so please ask for an evaluation copy of SimWare, and of course, if you want to get involved in the LSA group, we can put you in contact with the chairman of that group, which is Dan Gregory from Thales Group. Thank you again, and have a nice day.
Thank you.